Hello again, this is Joseph. Continuing tutorial about this is actually the power distribution system. Whenever you want to know where the fuses are related to and what circuit they apply to, you always go to this page, and it's a much easier visual outline to understand where the fuses go in a quick visual inspection, so to say. So let's say, for example, this is a module. This is in charge of body control module, is always in charge of the accessories. By that I mean the power lock doors, the lighting, the other things also, anything to do with accessories, power windows. This has to do with accessories. The PCM, the power control module, has to do with the engine performance, the air-fuel ratio. So each each module has their purposes and their responsibilities. Over here, when you see a dotted line, it means this is a module, and it's continued with on other pages with more pins. So let's say this is pin 1, pin 4, pin 3, pin 2, pin 2, pin 2, pin 3, and this is X2. It's a different column. X3 is a different column or row. X4 is a different column or row. So therefore you have to be in the correct one, the correct column or row that you are looking at. You can have pin 2 here, you can have pin 2 here, pin 2 here, but they might be from different columns. So besides that point, how to read the schematic, like we said before, there's always a battery involved, obviously. Now, the battery on this case, we're talking about Chevy Express vans. It depends if it's 4.8 liter or 6.0 liter. But this battery is for both, as you can see. Now, it goes through a fusible link, which is wires that are connected together, meshed together, soldered together, or melted together. Whenever the current rating is exceeded, they melt, almost like a fuse. So therefore, and it's used a lot around the battery. Now, if you see over here, we're dealing with one single battery. I always teach in these courses, I always teach how current flows. If you see many videos, it discusses power. It says, if we have power here, we have power there, we have power. That, if you understand how current flows in the circuit, you'll be able to figure out where the 12 volts is. Current flows from the battery. So we have current flowing, not voltage. Current flows from here. One side of the fusible link comes out the other side of the fusible link, which is red, Therefore, this is 12 volts with respect to ground. Where is ground? This is ground. The negative, the small bar over here is the ground. Where does ground go to? Ground goes to the engine, the block engine, the engine block. So therefore, current flows comes in here, comes out the other side of the fusible link, link 2, goes over here. Now, when it comes to this point, current can flow in many, many paths. As you can see, why? Because there are many fuses. And why is that? Because there are many modules. So, like we said before, this dotted line represents a module. This represents also a unit, a blower motor resistor, which is whenever you have problems with the speeds of the blower fan, it only works on high, it doesn't work on the other speeds. This is the culprit over here. So the blower motor resistor is a unit. Engine control module is a module also. So therefore, every fuse has a purpose for it. However, look how many fuses are related to this one module. We have about 6 or 7 fuses related to the BCM. Why? Because this BCM, or the body control module, is responsible for the ABS system, the restraint system, the airbag system, the locks, the lighting, has a lot of responsibilities. Power unlock doors, power doors, heated seats. So all these things come from here. Therefore, you're going to find a lot of fuses around this one. Now, we just said current flows, but over here I took the opportunity of putting 12 here, 12 over here. Obviously, that represents the voltage. When you understand where current flows, you can understand there will be a voltage drop between ground and this point, 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 between ground and this point. We always leave one probe at rest. And with reference to that point, we say, with respect to this point, this is 12 volts. With respect to this point is 12 volts. With respect to this point is 12 volts. So therefore, we don't need two probes moving at the same time. One is at rest, and that's the black one, or reference to ground. So, let's continue. Ground goes here, has many paths. Current has many paths. Current will flow here, divide go here, divide go here, divide go here, 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 here. Wherever you see a branch, this is a branch, a node, a branch, it will divide and it will go in that path. As you see, there are many, many paths. So therefore, again, current flows, voltage does not flow. So, but once we understand that current is flowing, we can understand what the voltage drop should be. 12 volts should be here. We'll connect it right to the battery. 12 volts should be here. Why? We said current is flowing, but there's no voltage drop across here. We do not lose much. There is very low resistance. So 12 volts here, 12 volts here. Why 12 volts here from here to here? Why? It's a wire. We're not going to lose much voltage drop. By voltage drop, I mean from this point to this point. With respect to 2 points, the voltage drop, the voltage will be 12 here, 12 here. If this was 12 and this was 10 volts, that means we just lost 2 volts across this component. If this was 12 and this was 5 volts, we lost 7 volts across this component. So therefore, if this is 12 volts and this is 12 volts, we lost 0. Or maybe 0.1, 0.2, which is negligible. We consider it 12. Again, we come here, this is 12. Why? This is a piece of wire. You remember we discussed about parallel circuits? Well, these are all in parallel. This is going 12 volts here, 12 volts here. Why 12 volts across each one? Because these are a piece of wire. If I have 12 volts over here at this fuse, how much should I have over here? Same concept, 12 volts over here. That means the fuse is good, because I do not lose any voltage drop across this point to this point. If I have 12 volts over here, but I have 0, how much did I lose? I lost 12 volts across here. Obviously, this is open. Now, other thing to understand about these things, these diagrams. Whenever you look for something, let's say an engine control module, I'm looking for the fuse that controls the engine control module. This representation of power distribution gives me right away the fuse that's responsible for that one. In this case, it'll be ECM battery fuse 10 amps. So if I go to the fuse distribution panel under the hood, and sometimes it says on the panel on the cover, it'll say ECM battery fuse. That's what I'm looking for. Sometimes it says it. Some models or makes of models, it doesn't. They don't specify what the fuses are. So therefore, ECM blower resistor fuse is the blower motor resistor. ECM battery is responsible for engine control module. What do we see from here? We see that there are no switches. Hot at all times. Current can flow through this one to the engine control module right away. Even when we don't have the key in the ignition, even when we don't have the start, even when you close the door, it seems like current is always there. 12 volts is always here. You do not see any switch. Do you see any switch? Do you see any relay from this point to this point? No. Do you see any switch or relay from this point to this point? No. What does that tell me? That means the body control module is active at all times, regardless if I'm in the vehicle, out of vehicle. It's like keep alive memory. This always is alive. How do I know? Look, there are no switches, there are no relays. There is a straight path right through a fuse. As long as that fuse is good, this will have 12 volts. It has to, because it has to keep the memory. How does your radio stay on all the time? It has memory. Now, if you look at the other things, when you come to this point, this triangle refers to another part of another circuit, another diagram. A refers to another diagram which you would have to find. Let's say somewhere else there's another part, and it would be called A. Therefore, A would be connected to the other part, which is A. Okay? Now, a couple of other things. Look how many modules are involved. A lot of modules, a lot of units. When troubleshooting, and I always get asked this a lot, the first thing that people have a tendency to do is, let's go check the fuse. You start off with the simple things. True. However, not everything in automotive diagnostics will be the fuse. I wish it was, but it's not. How do I know if it's fused or not the fuse using a schematic? Well, let's say when I had the problem, set the console accessory power receptacle, and this one is labeled console 1. This is console 2. These are the units where you charge up your phone, for 12 volts. You put in your charger, one on this side and one on that side. The other ones go to ground. So anyway, one was not working. Right away, of course, what do people say? Is the fuse. It's the fuse. But we're technicians, so what are we going to do? When you have a problem like this, and you want to know if it's the fuse, and you have the schematic in front of you, you see if there's anything else connected to that point. We're dealing with this point, correct? This is the problem. I went to measure at this receptacle. I did not measure 12 volts. I measured 0. So obviously I know there's a problem. That's why obviously the charger is not working. Now, I see another path over here. We're dealing with obviously lighter DLC fuse. Rated at 20 amps. As you will see, there is a color code for the fuses. They could be green, they could be yellow. Yellow is usually 20 amps. 15 amps, some are red, some are green, according to the color code. So sometimes they have, obviously, the amps written on them. 20 amps, 30 amps. But let's say it's erased. Let's say I cannot see it. Tomorrow, hopefully I'll do a video if the weather gets better. You'll see the fuses. Let's say it does not say how much the ampage is on that fuse. Let's say it's a yellow fuse. I'm expecting 20 amps, but I don't see 20 amps written on that fuse. I look at the cover to tell me LTR DLC fuse. I look at it, I don't see that. So you know what I do? I'm going to go to all the yellow fuses because I check all the yellow fuses. And maybe there's about 3 or 4. Why would I do that? Because I know I'm dealing with a yellow fuse. 20 amps is yellow. Color-coded. Like the resistors. Resistors we used to have color-coded. Brown, black, red, orange. Same thing almost here. But when we come to this point, if I want to know this fuse is good, what do I do without even measuring, without even putting a fluke meter? This goes to the receptacle that we just said. I don't have 12 volts over here. I put it in my charger to charge my phone. Nothing. Fine, we know this is inactive. But there is another line over here. Data link connector. DLC refers to, you got it, data link connector. And what is this? This is where you put in your scan tool, your scanner, to read the codes. That's always under the steering wheel, under the dashboard. And it tells me that pin 16 goes to this point. Now, of course, what do? I put the scanner in, or I put my meter in. There's 2 rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I go to pin 16 with respect to ground. Now, it tells me pin 16 gets how much? 12 volts. I go to this pin 16. Remember, let's say this is the data link DLC. Let's say this is the DLC, which is not. DLC. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. At this terminal over here, pin 16, I measure 12 volts. What does that tell me right away? That tells me that this fuse is good. I do not have to go to the fuse panel to measure the fuse. Why? Because I have 12 volts at this terminal, which is pin 16 to this data link connector, which is a connector on the bottom. I put my scanner in, it works. I know this fuse is good, even though this is not good. So what's the conclusion? Could be this one is open. This line is open. Could be this power receptacle is bad. There is a connector that goes to the back of it. Like the cigarette lighter, you have to take the panel out. Sometimes for GM, there's a retainer, a black retainer. Then the actual receptacle goes inside of it. Well, the back of that one has a connector, 2 wires, 12 volts. Could be the connector maybe broke, or it could be the receptacle itself is not good. But for one thing for sure we know, the fact that I had a scanner, the fact that I measured 12 volts over here tells me that this fuse is good. So whenever you see something, a fuse, look where else that fuse is connected. Let's take another example. Let's say this was connected to headlamps, parking lamps. And this is connected to the receptacle. I charge my phone. Nothing is at this receptacle. But I know the headlamps are on. I know the parking lamps are on. What does that tell me? That tells me this fuse is good. I did not even have to take a meter to measure the fuse. Why? If this fuse will be bad, that means everything connected to it, including my parking lamps, headlamps, will be off. That means this fuse is bad. You don't even have to need a meter to do this. So therefore, now let's go to relays. When I see many videos, I see that they express terminology always in power. This has power here, this has power, this is power, this is 12 volts. That's not going to help someone to become an automotive technician of diagnostics. It confuses the person. This is why I teach in all the videos that I teach current flow. As I specified before in the videos, 2 things have to happen for a relay. And relays are all for fuel pumps, for the lights, for everything. Once you understand one, you'll understand all of them. 2 points have to be connected to this coil. This is a coil that gets magnetized as current flows through it. Creates a magnetic field. If you see this dotted line, even if you're not familiar with relays, this tells you one thing. This pulls this one in. That's why there is a dotted line, a gang line. This tells you when this is active. What do I mean by active? I mean current is flowing through it. From 12 volts to ground. There's a complete path. And let me stress that. You have to have 12 volts on one side. And this will be terminal 86. The other terminal 85 goes to ground. That is a complete path. Current has to flow through a complete path. And if you want to know where the ground is connected to, G302, which is left kick panel. This even tells you where it's located. So therefore, we need 2 things first to operate. The first thing of a relay is we need this part of the circuit to be activated. This is number one priority, number one. When this happens, number two can take place. There's 12 volts here. Sometimes 12 volts can come right from a fuse, sometimes from the ignition switch, sometimes from a computer. If we have the ground, that means the 12 volts is coming from somewhere else. If we have the 12 volts, but we don't have a ground, the ground can be coming from a computer, giving it a ground. Current flows from the 12 volts through one side of this coil, right? At 86, terminal 86, the current leaves that coil, comes out the other side, which is terminal 85. Goes to ground, back to the battery. Fine. That accomplishes a magnetic field, pulls in the contacts, and now guess where terminal 30 and terminal 87, now it's closed. We just closed this side. So this went from here to here, now goes from 30 to 87. And all the relays, the relay box you'll see are labeled with this, 85, 86, 85, 87, 30. And always remember, if you want to remember how it works, again, look at the dotted line. The dotted line means it is pulling in the contact to close this, the armature, to close this circuit. Current flows here to ground. Then current can flow from terminal 30 to 87, out of terminal 87, through one side of the fuse, come out the other side of the fuse, and then go where it has to go in these paths. So if you understand the current path, let's understand the voltage. I have 12 volts over here. How much should I have over here? If current is flowing through this, I should have a voltage drop across this. Since this is connected to ground, I should have 0 volts here. How much is the whole voltage drop? 12 volts across here. 12 here, we have 0 here. That means we lost it somewhere. We lost it across the coil. Fine. This tells us this is operating. This is also connected to another 12 volts, right? Might be the same as this one, might be a separate one. Doesn't matter. 12 volts over here. How much should I have? I have 12 volts at 30, terminal 30. How much should I have at 87? 12 volts. Why? This is just a contact, a switch to call it. I do not have any voltage loss. So what I'm going to prove to you is, hopefully, like I said, we're going to go in relays and test relays. And I always stress one thing, one-shot troubleshooting. Where is a good place to start troubleshooting? And you know that I like one-shot troubleshooting. Where am I going to go to find a point that I can measure the voltage quickly and I can understand what's going on? If you see many other videos, they take out the relay. They say, okay, we measure 12 volts here. We measure on 0 volts over here at the ground. We measure on the load side. This is what I'm saying. When it comes to electronics, you measure everything in circuit. You measure the relays in circuit. You do not take out the relay. To me, that is absolutely of no use whatsoever. It absolutely accomplishes nothing. So all the videos that say, let's take out the relay because we can't